So in this example, we're going to be looking at jury selection and asking, well, do juries actually represent the public? Because that's kind of the point of a trial by a jury, to be tried by your peers. Important things to realize in this problem is, once again, we're looking to see, are they actually representing the public? And to test this, we're going to be comparing our data to census stuff. And so we have these percentages up here from the census, and we'll be comparing these percentages to what we have down here in our actual observations. Whenever we start a chi-squared test, goodness of fit, or test for independence, our first step will always be to calculate our expected values. And we're doing that because we need to make sure we have enough people to justify doing this chi-squared. So let's go ahead and put in our expected values column. Now, if we remember from the previous videos, we calculate our expected values by taking our sample size, or our total, and multiplying it by our expected percent. So when you look at this here, we know right off the bat that we have a total of 1,336 people. And based on my census data from up above, I know out of those 1,336 people, I would expect 6.1% of them to be between 18 and 19 years old, based on census. If juries are representing the public, I should see about that percent. So what I'm going to do to calculate my expected value for right here is I'm going to go ahead and I'm going to take my expected percent, which is 0.061 in decimal form, and multiply it by my total sample size, which is 1,336. I'll then go ahead and repeat the process when I go down to the next one. That is, if I want to go ahead and calculate how many 20 to 24-year-olds I expect, I will take the percentage of 20 to 24-year-olds, 15, and multiply it by my total again. So 0.15 times 1,336. So notice each time I'm just taking my expected percent, the percent from the census, and multiplying it by my sample size. Once again, when we do this here, let's keep 2 decimal places as we run through it. Filling in the rest of the table then, once again taking each expected percent times the total sample size of 1,336, we should get the following numbers. The reason why we do this before we even start a test is because we need to make sure that our chi-squared goodness of fit test is actually going to work. And the reason we need to check our expected is because, remember, each category has to have an expected value that's at least 5. Now, notice all of our expected are at least 5, obviously, so this means chi-squared goodness of fit is a test we can actually run on this. Now we've got our expected values, let's go ahead and clean this up a little bit and get on to talking about our first step, which is to list. Now within my list step, the first thing I do is list the number of categories, and looking over there on the side, it looks like I have 7 categories. This leads me to find my degrees of freedom, which is the number of categories minus 1, or 7 minus 1, which is 6. My second step is to go ahead and list my hypothesis. My null hypothesis is always the distribution fits. Now, in this case, when I talk about the distribution fitting, I'm talking about the fact that the jury is actually representative of the public. So that's what I would actually write. Jury represents the public. Now, this is what I'm assuming. It's kind of my wholesome thing that I'm focused on, but it's not what I'm trying to prove. I'm trying to prove the distribution does not fit. Or in this case, the jury does not represent public. So once again, my null hypothesis, kind of that wholesome assumption everything's equal, jury represents the public, HA, my alternative, the opposite of that, jury does not represent the public. Now I've done this, the next thing I need to do is go ahead and look at step 3. Step 3 is my test statistic. This is where I'll calculate chi-squared. And to do this, I need to go ahead and add some more columns onto my table. So moving things around a little bit. We now have room to expand our table out a little bit. So we've got observed and expected. Our next step to calculate chi-squared is to take our observed and subtract off our expected. Now remember, some of these numbers will be negative, like the first one when we take 23 minus 81, and some of them will be positive, for instance, when we take 297 and subtract 204. So adding in all these numbers then, we get the deviations, that is, how far off our observed is from our expected. After we've done this, the next thing to do is go ahead and add in yet another column, and this will be where we take observed minus expected, we square it, and we divide by expected. As a reminder, we combine these two steps so we don't have to worry about a whole bunch of rounding. So finding these numbers then, after I go ahead and add in all of those, my final step to calculate chi-squared is to take all of those and add them up. This will give me chi-squared. And the thing to notice here is that that is a really friggin' big number. It is large. What this tells me is that my observed are really far off of what I would expect if in reality juries did represent the public. So there's a lot of difference between what I'd expect to happen if my assumption's correct and what actually did happen. So that we've gone ahead and found our chi-squared value. The next step is to go and find my p-value. So I'm going to write that right over here. When I go to find my p-value, I need first of all my chi-squared table, and then I'm going to be looking across degrees of freedom 6. Now, as I look across degrees of freedom 6 here, I do notice that my chi-squared of 231 is not on the table. In fact, a chi-squared of 231 would be way the heck over here. It's way off the table. Going across the top, remember, my p-values are getting smaller and smaller and smaller and smaller, just like on this t-table, which means when I trace 231 to the top and get my p-value would be smaller than that 0.0005. That is, my entail is less than the smallest entail up there. Using this then to go on to step 5, which is my conclusion, I always compare my p-value to 0.05. Well, I know my p-value is less than 0.0005. If my p-value is less than 0.0005, my p-value is definitely less than 0.05. Because my p-value is less than 0.05, I'm going to go ahead and reject h0. When I reject h0, that means there is enough evidence, and in this case, there is enough evidence to suggest what I was trying to prove with my alternative hypothesis, which is juries do not look like they actually represent the public.